All right, question number 17. We want to determine the intervals on which the following function is concave up or concave down. And so in order to do that, we need to find the second derivative. So we have f of x is negative e to the x times x minus 3. We're going to have to do the product rule even if we distribute. So we'll do 1d2 plus 2d1. So this is the first function, derivative of the second, second derivative of the first. All right, so first function for f prime is negative e to the x. First derivative of the second, derivative of x is 1, time minus derivative of 3 is 0, so just 1 times 1, and then plus the second function, which is going to be x minus 3, times the derivative of the first. Derivative of e to the x is still e to the x, and that negative constant just stays with it. From here, simplifying, I will factor out a negative e to the x from both terms. That will leave me with 1, and then plus the x minus 3, and then that will simplify to negative e to the x. 1 and 3 will combine and give me x minus 2. All right, so here's f prime. And then we'll find the derivative of this, so f double prime. Same thing, product rule. 1d2, 2d1, so negative e to the x times the derivative of this one would just be 1 again, plus derivative of the second. The second function times the derivative of the first, which would be negative e to the x. And then factor out negative e to the x again, leaving us with 1 plus x minus 2. And ultimately, we will end up with negative e to the x, not negative x up here, so just a negative here, e to the x, x minus 1. All right, so here's our second derivative. We're going to take this function, factor it, set it equal to 0, find the critical values. Say 0 equals negative e to the x, x minus 1. So this function will equal 0 if this equals 0 or this. E to the x will not equal 0. It's not in the domain. So we'll get a critical value from x minus 1 equals 0. Add 1 and we get x equals 1. So we have one critical point. It's just 1. All right, so I'm going to pick a number left side of 1, 0, right side of 1, 2. Pick something relatively easy to work with that we can solve. If I plug in a 0 here, e to the 0 power is 1, but it will become negative because of that multiple. So I'll get a negative for that part. If I plug in 0 here, negative times a negative will give me a positive. So this first part is concave up from negative infinity to 1. Negative times a negative, we get a positive. Now if I plug in 2, e is 2 point something times itself twice, maybe 4 point something, or it's going to be positive, but this term is going to turn it back negative. So I get a negative for my first term, and then 2 minus 1 is going to be a positive 1. So I have a negative term times a positive term, and that's going to come out negative. So this first section, negative infinity to 1, concave up. 1 to infinity is concave down. Inflection changes between the two, so this is a inflection point, or concavity changes between the two. All right, so we are looking at option A, concave up, concave down. And we're going to say concave up on negative infinity / negative infinity to 1 concave up and concave down on 1 to infinity. All right, and then it wants us to locate inflection points. So inflection point was at x equals 1.